All right, in this last example on page 41, we are given, we're talking about a function f. F is defined on the closed interval from -2 to 7, and we're given the graph of f prime. And so we're going to be asked some questions about relative extreme values, where f is increasing, and then also the concavity. So just a quick reminder that when we're using our first derivative, OneNote's not letting me scroll. When we're using our first derivative to think about concavity, that's not where our first derivative is positive or negative, rather where it is increasing or decreasing. So we know the sign of our first derivative informs whether our function itself is increasing or decreasing. But if our first derivative is increasing or decreasing, that informs us of the concavity of our function. All right, so in number 41, the first thing we're asked to do is to give the location of all relative extrema of f. So if I'm looking for relative maxes and mins, I know that I'm looking first for points where f prime is equal to 0, or where f prime is undefined. Well, this is a graph of f prime, and it's never undefined from -2 to 7. So where f prime is equal to 0 is going to happen at 2, and it's going to happen at 7, but I'm going to point out that 7 is also the end of this closed domain. So it's not really, I can't really say that 7 is a relative max or min because I don't know what comes after 7. So 7's not the location of a relative max or min. I can kind of rule that one out. So let's see what's happening when x is equal to 2. So again, on a number line, I might do my closed interval from -2 to 7 and just throw my 2 on there. And if I think about f prime, well, f prime is negative from -2 to 2. So again, I'm looking at the sign of the derivative, which on the graph, I'm just looking to see where my function is negative. Sorry, OneNote's not really letting me switch between, I was trying to switch between the pen and the highlighter tool. So f prime is negative on that interval. And then f prime is going to be positive, come on OneNote, on this interval. So where f prime is negative, that is where f is decreasing. Where f prime is positive, that is where f is increasing. And I could see that 2 is the location of a relative minimum. So again, I always need to justify my answers. So I could say f has a relative minimum, I'm going to abbreviate, at x equals 2 because f prime changes from negative to positive. All right, so we could use that same number line to answer question B, because for question B, on what intervals is f increasing? Well, we already found that out in our number line. We said f is increasing where our first derivative is positive. So f is increasing on the interval from 2 to 7 because f prime is positive. You can say that in words. You could write an inequality. So in part C, on what intervals is f concave down? So now in part C, we still want to think about our first derivative, but where it's increasing or decreasing. And sometimes what is hard is that our brain very much wants to switch, and it wants this to be the graph of f. So something that helps me to kind of think through this is again, where f prime is positive, that tells me f is increasing. Where f prime is negative, f is decreasing. And I don't necessarily know anything about my second derivative here. But I do know where my first derivative is increasing, that would have to be my second derivative is positive, f is concave up. Where my first derivative is decreasing, my second derivative is negative, and our graph of f is concave down. So sometimes that little table, that little chart is kind of helpful for me to think about. So again, I'm looking for where my first derivative is increasing or decreasing here. So because I can, in OneNote, I'm going to just erase my highlights. So I could see that f prime is increasing from 1 to 3, and that f prime is decreasing from -2 to 1, and again from 3 to 7. I could just visually see that on the graph. And again, if I remember, when I'm looking for candidates of points of inflection, I'm looking for anywhere my second derivative is 0 or undefined. These are both examples of where the second derivative would be undefined, just to point this out. So my second derivative is not 0 at x equals 1. It's undefined because f prime is not locally linear there. And at x equals 3, the same thing. F prime is not locally linear, so the second derivative cannot exist. All right, so to answer this question, we said that f is concave down and we said this is going to be on the interval -2 to 1, but then again on the interval from 3 to 7. So we could just use the union symbol there to join those intervals. And we said that this is because f prime is decreasing. So again, while it's true that our second derivative is negative here, that's not the reasoning we're going to use. Kind of going back to this idea of claim, evidence, and reasoning, the evidence that we have is the graph of f prime. So if we talk about our second derivative being negative, we would have to say how we know that. And again, we know that because f prime is decreasing. All right, in part D, what are the locations of the inflection points of f? Justify your answers. Well, again, we said inflection points happen when we change concavity. So that's going to happen anytime the second derivative changes signs or the first derivative changes from increasing to decreasing or vice versa. So again, this is happening at 1 and 3. So we could say that like f has a point of inflection at x equals 1 because the first derivative, f prime, changes from decreasing to increasing. And then similarly, f has a, I'm going to abbreviate POI here since I already said point of inflection at x equals 3 because f prime changes from increasing to decreasing. All right, finally, in part E, well, I didn't read ahead because we already talked about this one. For what values of x is the second derivative not defined? Well, we said this verbally a moment ago. That's going to be, again, at x equals 1 and x equals 3, because that is where f prime is not locally linear. We could also say that f prime has a corner there. So at x equals 1 and x equals 3, f prime is not locally linear. Therefore, the second derivative does not exist.